Okay, so it looks like we're ready to move on to our next set of skills. The things we're going to go over are listed here. Aligning cells and using text wrap and using Autofit. Column totals and total cell styles. Totaling up rows also. Formulas for percents of a total column, which is then going to be creating a formula and replicating it throughout cells while using an absolute value versus a relative value when using autofill. Applying functions on ranges like total, average, maximum, minimum, etc. How to build pie charts, cluster pie charts, resizing the charts. And then some other ancillary stuff like word art and scaling the height of a page. When you go to print off a page in Excel, how much do you want to come out on one page of Excel? Okay, so aligning cells and text wrap. So we could put text into a cell. Like here's the cell A1, and we say a wise old blah, 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 blah. And then all of a sudden we go to, well, we're saying a wise old owl lived in an oak. Okay. Now, if somebody comes along and types something into the B cell, whatever they start with will override the rest of this sentence. So this sentence is overriding into the B and the C cell because there happens to be nothing there. But if there was something there, then we would see what's there and not what's here. And we might want to make this cell bigger so that this sentence can wrap around and you know, if we can make this row wider, then we can fit everything into it. So what we could do is we could go on our home menu, we could go select text wrap and apply that to this cell, and now the cell will get wider in the event that there's data in the B1 cell. So that's how text wrapping, that's the idea behind text wrapping. So you could pick a range of cells, and then you could click on text wrap, and then those will never have any of their data overwritten by data in the cell next to it. Okay. Auto-fitting data to a cell would be where you want the columns or the rows to stretch so that it's big enough to cover what you've typed in. So for example, you can make the font much bigger in column A and much smaller in column B, and it's very possible that the thickness of the row might be too thin and it starts squishing away some of these letters. So if you made it auto-fit, if you wanted to auto-fit and you said, I want to auto-fit the row height or auto-fit the column width, then what you could end up doing is you could make the row thick enough to fit the thickness of your word, and it can make the column wide enough to stretch out to fit the biggest piece of text in that column. And it would do that automatically. If you deleted that biggest piece of text, the row would shrink because the row is auto-fitting to the it's auto-fitting to the size of the data in the row. Okay. So now another thing that we can do is we can have, here, let me get that, thanks. Okay. The other thing that we could do is if we could do column totals and also do a column total style, like if you want to look like a professional accountant. So in chapter 2 of our text, suppose we had a spreadsheet that had, for example, January, February, March, every month of the year, all of our sales. And suppose we have our expenses, looks more like, hopefully these aren't sales. Cable TV, $52.98. Video rental, $7.98. Movies, I guess if you go out to the movie theater, $16. And then CDs, $18.98. So you're trying to calculate how much money you spent on entertainment for the month. What you can do in this bottom cell, you could say, here are my totals. And you could say, this equals, now we're putting in a function, not a formula. And we're basically saying that value that goes into this cell is equal to, so we use an equal sign, equals sum, S-U-M, if you want to sum up a range of fields, and it could be two-dimensional range of fields too. Could be a row, could be a column, could be a subset of a column. So we could say, I want this box, the value in this box, to be equal to the sum of all of these boxes added together. Now, what you could do is you could click them one at a time and put a comma between them. I want this one, I want this one, I want this one, I want this one. If they happen to be, if you're lucky enough, or you strategize your spreadsheet enough, to have them in a row, like, or in a column actually, have them all in the same column, what you could do is you could say this box equals sum, S-U-M, open parentheses, and then just click on this box and hold your mouse, the right button, and just shade over this area. It'll draw a rectangle around it, which will then put in the addresses B3 to B6. So that's, we're taking column B, row 3, this value, all the way down to B6, this last one, and it assumes fill in the entire rectangle between these two squares. So if we wanted to, we could say sum from this box to this box, and what that would do is it's sum these 4 boxes plus these 4 boxes. It would mean the whole rectangle, everything would get summed up. If for some reason you wanted to sum up numbers that are not next to each other, if you wanted this one plus this one plus this one, you can still do that. You could say equals sum, open paren, click on this box, say comma, this address, comma, this address. You can pick them out one at a time, but if you're lucky enough to have them all in a row or in a column, then you could just say from this box to this box, and it assumes you want all of them. It's a little bit dangerous if you put in a formula like this and then you insert a row, and for some reason the row you're inserting should not be added into this sum, it's going to automatically get added. When this thing stretches, this is just going to make a range from B3 to B7 if you added a row. So just keep in mind that. So once you type in this function and you hit enter, it'll actually do the math. It will add these numbers up and actually print it. It would look like this. It would say $95.94 is how much money you spent on entertainment. Okay, so that's summing up a bunch of columns and having them equal a total. And you could say, you could put in here, you could put words like total, and then you could shade this row and make it like an accounting total style. That's kind of like some ancillary stuff we'll do at the end of, the section when we do our homework. We can do that. So now, if you were to click on this box to say what's in it, did somebody come along and type in $95.94? Or is this a formula from somewhere? So if you click on the box, you could look up here and it'll tell you, oh, this box has actually got its data from this function. So it's basically saying the $95.94 came from adding these 4 numbers together. Okay, so that's good. Okay, now, if we want to do, let me go back to this. This number, 95.94, is money, right? And maybe it's US dollars in a sense. So we might want to have it look like currency, have like a dollar sign in front of it. Okay, we can format ourselves, if we have numbers, we can format ourselves many, many ways. And one of them that's kind of interesting is when you do a percent. So let's say, for example, we had a spreadsheet where we're, again, calculating expenses. So let's say we have rent is $700, and groceries is $200, and internet is $70, and entertainment is $150. So this might be somebody's expenses for a month. Now let's say, for example, we wanted to calculate what was the total. Well, we know just from our last slide, the way we calculate a total is we would have here in a box, we don't have to put a rectangle around it, bracket, but we have a box here, and say this equals the sum of this plus this plus this plus this, and it will equal that number. Put that formula in place, okay? And now, suppose we wanted to know of our total, what percentage of it is spent on rent, what percent is spent on groceries, what percent is spent on entertainment, and what percent is spent on, so what are the percentages of each? Let's say you wanted those. All right, so we can make a heading called percent of total. And now we would need a formula. Now a formula for this box would end up being, and we can see a formula right here, a function of x. It's right here. This box gets its value from taking the box C6, this box, $700. So this is a number we manually typed in. So this box divided by this box, that's what percentage this would be over this. Okay, so you might think you'd see a formula that says this box, and I'm clicking on this box so I can see the formula for it. And the formula says, take this box and divide it by C11. Now you see the C11. Now, there's two dollar signs here. This is what the point of the dollar signs is. This has to do with the concept of absolute addressing. So the idea behind absolute addressing is this. If I want to take this formula, pretend this is blank, blank, and blank, and I've put in my formula here, and I say this box equals this box divided by this box, right? This box divided by this box. I put that formula here, and then I go to autofill, because these three boxes should have the same formula. So I grab this little square in the bottom, and I just drag it down here, and it fills right in, right? What would happen? Well, this box here uses, this box is in the D column. It's using one column to its left as this box, and then it's using one column to its left and 1, 2, 3, 4, 5 rows down as its denominator. So the numerator is the number one box to the left, and the denominator is one box to the left and 5 rows down. So if you autofill this, if you took this box as is and dragged it here, the calculation for this box would be the box to the left as a numerator, and for the denominator it would be the box to the left, and then 1, 2, 3, 4, 5 rows down. Because this thing isn't smart enough to know that this denominator doesn't move down. It wouldn't know that. You know it because it's your total. You want to always divide by this box. But if you're autofilling, the autofill is just taking the box where you currently are, and it replicates the formula based on the boxes, how far to the left and how far to the right and how far above and below they are. So those are called relative addresses. When you're replicating this formula, the numerator is, its location will be relative to this box, relative to this box. It will be 1 to the left. The denominator is relative to this box. It is 1 to the left and 1, 2, 3, 4, 5 down. Its relationship to the box. So when you autofill, the address of the boxes in this formula get replicated here, but relative to where they're located compared to this box. Sometimes you want to not use a relative location, but you want to use an absolute location. You want to say the numerator is the box to my left, but the denominator will always be this box. I don't care how it's related to what box you're filling in. I always want to use this box. I don't want to use any other box. And that address, so the address here is C11. That's called the absolute address, not the relative address. So the idea of relative versus absolute is like this. Suppose somebody sent you an email and said, I'm going to come to your house in 3 days. Well, when are they coming? Well, they're coming 3 days after the email was written. So now you'd have to look, when was the email written? Then calculate 3 days after and go, oh my God, that's today, because the email's from 3 days ago. So when you say 3 days from now, that's a relative time period, right? It's relative to whatever today is. But if you say I'm coming to your house on April 10th, whether you saw the email a week ago or you're seeing the email today, you're coming April 10th. It's an absolute date rather than a date relative to some other day. So if we wanted to give an address and make it absolute because we plan on copying it, you could make it absolute in Excel by putting a $ in front of either the row or the column or both. So by saying this box is calculated by taking C6, which is a relative address, C6, and dividing it by $C, $11, column C, row 11 with a $ in front of it. That means if this formula gets copied, this address, C11, should never change because it's an absolute address, not a relative address. So by making this formula, C6 divided by $C, $11, what that means is if I now grab this corner and drag it down here, this box will be calculated as the number next to me divided by this number. Not the number below this one, but this one. This box will be calculated as the number next to me divided by exactly this number. This one will be this number divided by that. So that's the point of the $ sign. Actually, it could have gotten away with, the only thing we really cared about is that the row number doesn't change. Could have got away with the $ in front of the 11. You don't really need the C because it will always be the row next to us, and that would always be where this number is. So the $ sign here wasn't necessary for what we were trying to do. Very important that this $ sign was there, the $ sign in front of the 11. Okay. Okay, now if you happen to have a row of numbers, you can do things, there are other functions that will do things like tell you what the minimum is, the maximum is, what the average is. Other aggregate functions where you go through a bunch of numbers, you get the median. That's the middle one, not the average one. So for example, we could have for these sales, we could say we're running a hardware store, we have hardware, software, consulting, total, much more of a software company, sorry. And then we can have all the different customers. And so out of all of these, we could say, well, what's the largest number out of all of these numbers in this row here? So we can click on this one, and it would be the maximum from B4 to B9. Whatever the maximum number is out of these, which looks like this one, that'll show up here in this box. Could put in this box the minimum of all the numbers between B4 and B9. And the smallest number here looks like this one. So the smallest one shows up. And then the average, it would do the computation of adding these all together, which you could do yourself. You could say equals sum, and then you could say divided by the number of elements, 1, 2, 3, 4, 5, 6. You could have said divided by 6, but you could also say divide by the count of all of the numbers in the range. It would count them up for you and divide by 6. But since that's such a common thing to do, to have averages, Excel builds in an average function for you. And then what we can do is we can take these three formulas, shade them, and then just drag them over here. They're all relative, so we wouldn't have to put in any $ signs. And we can just put the three formulas here and then auto right? Just copy them over, right? Wouldn't need a dollar sign. Okay. Okay, now the other thing you can do is you can take rows and columns of data and you can make pie charts out of them. So for example, we could have regions like north, south, east, west, central, and we can have a percentage of something, anything we want, really, sales or anything like that. And then what we can do is we can click on the charts, and then under charts there's two-dimensional pie charts, three-dimensional pie charts, broken out pie charts. And what we can do is we can shade one column, which is going to be our labels, and another column is our numbers. And we would like our numbers to add up to, they have to all add up to 100%. So if it doesn't add up to 100%, Excel will add them up, we'll do the sum of them, and then actually do what percentage are the numbers of the total. So it's actually doing, why this was a good choice, it would sum up, where's our, this one. So when we calculate, if we had these four numbers, and we wanted to draw a pie chart of rent, groceries, internet, and entertainment, we could shade this column to be the labels of the pie chart, and then we could shade this column to be the numbers of the pie chart, but the slices of the pie are always percentages that this number is of the whole pie. So what Excel would do for you is it would calculate these numbers for you and then make slices of pies based on these percentages, and then use these labels. And then even put these numbers in, but also make the pie slices the size of the ratio of that number to the overall size of the pie. In this case, we were actually nice enough to break out the percentages, and 86, 90, and as you can see, they happen to add up to 100%. But Excel would do that for you if your numbers were not already as percentages. You could also have a lot of data, not just a bunch of numbers and an equal number of labels. You could have multiple columns of data. So for example, for the first quarter, for the second quarter, for the third quarter, and for the fourth quarter, we may have, like our company has 4 sections to it, east, west, north, and south. So we might want to see these as a pie chart. So have one dimension being time, and another dimension being east, west, north, and south. And a third dimension would be for each of the quarters, what do each of these dimensions have as values? So now we have to do clusters of data and line them up next to each other. So if you think about it, this picture right here is really like a pie chart, right? Kind of like a pie chart, where you can see 4 different sections of a pie and how much each one is. You just don't quite get the ratio out of 100% how much they are. But then if this goes over a third dimension, like quarters of a year, first quarter, second quarter, third quarter, fourth quarter, then we can't represent it as a pie chart. Actually, we could have represented it as 4 separate pie charts. So these are called cluster charts. Okay, and then like I say, we have some ancillary topics. You can, when you start typing into one of the boxes, it's regular print, regular font, black print on white letters. But if you wanted to, you can, and this is, you probably recognize this from Microsoft Word. This is the word art. You could make your data have interesting looks and feels and styles to them. Okay, once you have your Excel spreadsheet and it looks nice on your eyes, you may want to send it over to a printer, and you find that everything that looks great on your screen comes out of the printer looking horrible because they print one page, and then on the next page you have the columns that are to the left of the first page. And so what you can do is you can go to the scale to fit, and you can set horizontally and vertically. You can set them to automatic. You can make the scale 100%, which means that 100% of your Excel spreadsheet will print on one page of paper. Just got to warn you, the print could be so small that you can't read it. So you got to use some kind of judgment when working on this. Okay. When you open up an Excel spreadsheet, at the bottom of the sheet, it starts you off with 2 or 3 sheets. I forget how many it starts you off with. And they're called like sheet 1, sheet 2, sheet 3. A lot of times you might just type data into the sheet that opens up and then you're done with it. But you could decide you want to have one sheet dedicated for each month of the year for your, let's say, your sales for the year. So for example, you could have one spreadsheet called September, and here's the data on our spreadsheet. We can scroll up and down and see the entire spreadsheet. And then you might want to mimic the same style on the October spreadsheet. So if you want to change the name from the name they gave you, sheet 1, to September, you can just click on it, and then you can type a new name on it. You can click on sheet 2 and type a name on that. If you want to add more sheets than the 2 or 3 that they give you by default, you could just keep hitting the plus sign and it'll add more sheets. And then you could always rename those sheets. Okay, so some of the topics we've talked about today, chapter 2, overlap with some of the stuff in chapter 1. And the next topic we're going to talk about, chapter 3, is going to pretty heavily overlap with this. So